Shoplight, the lighting industry's leading champion on sustainability and compliance. I'm Ray Molony. I'm the editor of the Circular Lighting Report, and I'm going to be your host for the next hour and a half or so. Now, today's webinar is entitled Bioplastics for Luminaire. So we're going to be looking at bioplastics and if they stand up to scrutiny as a truly sustainable material for luminaire housings and components and optics and things like that. Now, we have an excellent lineup of speakers, as you can see. We have Jamie Norris-Green, who's the founder of LumiAdd, which is a 3D printing specialist company, startup. We have Mark Shortland. He's the managing director of Shoplight, which, as the name implies, is a retail lighting specialist. And we have Julien Vaissieres, he's the CEO and founder of Batch.Works. It's a really interesting outfit out in East London, and they're a circular manufacturing company, and they've been working with bioplastics for about 7 years now. So we'll be interested to hear his experience with them. And also at the end of that, joining the panel discussion, will be the CEO of Recolight, Nigel Harvey. Right, today's agenda. First up is Jamie, and he's one of the co-founders of LumiAdd, and he's going to walk us through his experiences that he's had with printing with bioplastics and standard plastics. Next, Julien will talk, it's going to be Mark next, and he is going to tell us about some innovative spotlights that his company has developed, which use bioplastics. I think you'll find it very interesting. And finally, Julien will tell us about Batch.Works and what they're doing to help us in the lighting industry. And the presentations will be followed, as I said, with a panel discussion. And here, as normal, we will welcome your thoughts, your comments, or any questions that you have about bioplastics and about the experience of the companies using them. So, as I say, we'll finish at about 12:30. Today's session is being recorded, and it will in due course appear on the Recolight website. So as you don't have to take notes, you can just listen at your leisure, and you can listen again. If you go to the website and just follow the clicks, you'll be able to watch the whole recording, stop and fast forward and all the rest of it. You will also receive the slides tomorrow sometime via MailChimp, so keep an eye out for that. And if you don't get them by the afternoon, just check your spam folder if they've gone in there. Now, my colleague Suzanne, she's taking care of the chat box, so if you have any technical or any other issues or queries about the webinar, put them in there, and Suzanne will do her best to assist you. Please put questions or comments in the Q&A box. Now, I say this because I'll only be looking at the Q&A box during the event. So if you have any questions, and you put them in there and I'll put them to the panel. Before we start, a few future events to get on your radar. Simon Fisher will be running a number of one-day in-person workshops on remanufacturing this year. And as you know, Simon's an expert in TM66 and how you design luminaires to get good metrics and all that type of thing. He'll be looking at design principles, compliance. He'll also talk about the new draft remanufacturing standard, BS 8887, which has just been published. So if you're in now, these workshops, there's going to be some in large cities around the UK, but also if you want Simon to come to you and conduct a special workshop for your team, bespoke to what you're looking for, then he's happy to do that as well. So just get in touch with the team via the website. And of course, I also want to get on your radar Circular Lighting Live, which is our big event. It's a one-day conference and exhibition. It's our flagship event. And we believe it is the biggest UK event dedicated totally to sustainable lighting. It takes place at the Royal College of Physicians in London. That's by Regent's Park on Wednesday, the 9th of October. And the good news is there's early bird bargains to be had. So if you want to get yourself a bargain, get onto the website and get yourself booked in and ensure your place. If you're a specifier, an independent lighting designer, then you go free, but you have to register as usual and go through the registration process. Finally, just to say, as I said earlier, I'm the editor of the Circular Lighting Report. Now, this is a guide to the latest developments in sustainable and circular lighting. You can learn about the people, the products, projects, and the processes that are shaping our low carbon future. So there's loads of news stories in there. There's opinion pieces, and there's a good few video interviews that I've done with various sort of thought leaders, I would say, in the industry, and they're all there, so you can check on them and catch up. Again, you can follow us on LinkedIn, or you can go to the Recolight website and just the drop down where it says news and drop down to Circular Lighting Report. Okay, after all that intro, we're going to get on to the business at hand. So we're going to start with Jamie. So over to you, Jamie.
Thanks, Ray. Good morning, everybody. So I think a good place to start is the term bioplastics. So what is a bioplastic? I mean, a plastic material is defined as a bioplastic if it is either bio-based, biodegradable, or both. That's the definition from European bioplastics. So let's take the bio-based part of that. What does bio-based actually mean? I mean, some people might argue oil is bio-based. It's, you know, crushed up trees and organic matter from millions of years ago. So the reason I'm saying that, I think it's important to be transparency in the feedstock and understand what bio-based means. I think going bio-based is the right way to go and a great thing, but we have to be careful that people understand what that means. And there's lots of biopolymers that are actually only part bio-based, and obviously it's a good step in the right direction. But again, I think we need to delve down into what bio-based really means. There's many conventional plastics can be bio-based, so polyethylene, polypropylene, plenty more. And so the other part of that is the biodegradability. And again, I think we need some caution around this word biodegradability and degrees of biodegradability. So most of the polymers that I'm coming across that are labeled as biodegradable will only break down in industrial composting conditions. So not landfill or marine environments. It really frustrates me at the moment. There's a lot of single-use plastic stuff going around in PLA actually, and things like coffee cups and utensils, and they say biodegradable on them, and they say recyclable. We'll talk about that more later. But in the real world, if they end up in landfill, they won't break down. I mean, they'll break down quicker than petrochemical plastics, but it might be decades. So they don't really solve that problem in single-use plastics. So again, you have to be careful about biodegradability. But there's other polymers that are, the PHA, for instance. I'll talk a bit more about that, the biodegradability of that polymer. But I think we just need to be careful when we're talking about these materials and not get, you know, not greenwash essentially. We need to be clear about not oversell what they actually do. So plant polymers for luminaire construction. Now I'm calling them plant polymers because we made a decision to start saying that we 3D print all our luminaires in plant polymers rather than bioplastics, because we just feel it's a bit clearer, and we know that the polymers we're using are from plants. The feedstock is primarily sugarcane. So the two that we're using at the moment at LumiAdd are PLA, polylactic acid, and PHA. I never fancy pronouncing that one, so you can read that if you want. And again, the difference between the two, PHA is more it will biodegrade in any biotope. It will break down in marine environments. It's a little trickier to print with and isn't available in as many colors, but we're using it because we think it has a lot of potential, and we want more people to use it. I think maybe one of the barriers there is possibly cost, but we think it's a really exciting bioplastic. So why use plant polymers? Well, one of the biggest thing about plant polymers versus other materials is its low carbon footprint. I'll talk a little bit more about that on the next slide. It's renewable feedstock, so you know, it's not going to run out. We can regrow the crop, and it is biodegradable, as I said, but caveated there that, you know, PLA will only break down in industrial compost environments. But ultimately, we're not talking too much about the biodegradability of it, because I think that's a subject. It's more it's single-use plastics is where that's more important. For luminaires, we don't want them to end up in landfill. We have a buyback scheme with QR codes, and we want the luminaires back so we can either reuse them or recycle them in-house. So we don't want them to end up in landfill. that's not, that's not the right way to go. So talking about the carbon footprint, we often compare the material to aluminium. The reason we do that is that the parts of the luminaires and components that we're 3D printing in plant polymers replaces what most other manufacturers are making out in aluminium. So it's about 98% less CO2 emissions than aluminium. That I caveat that with that's aluminium that's sourced in the Far East, which makes up a vast majority of the aluminium used in the luminaire industry. But even if we talk about EU aluminium, which is lower carbon, because the stuff from the Far East is primarily the coal is used for the energy to produce the material. But even if we compare it to European aluminium, it's still nearly 93% less CO2 emissions than aluminium. And if we compare it to petrochemical plastics, it's 30 to 70% less CO2 than petrochemical plastics. Now that's a wide bracket because there's obviously lots of different petrochemical plastics with various CO2 footprints. But it's not hard to understand why it's a lower carbon footprint. You can see here on the graph that there's actually negative there. So the crop, the sugarcane, is taking in carbon from the atmosphere when it grows. And that's opposed to digging under the ground for oil and bringing carbon out, back into the atmosphere, essentially, potentially. So it's not difficult to understand why growing a crop and using that for a material is more sustainable than digging something up from under the ground. Now, I'm not saying we can use PLA for everything, and obviously we need aluminium for luminaires, for heat dissipation and things, but I think this slide is a good place to discuss aluminium again versus PLA. So we did a comparison with our surface mount downlight, and we replaced the outer housing with plant polymers rather than aluminium. There's a big, nearly 80% less CO2 there. Now, obviously, we need enough aluminium to dissipate the heat. And some people might argue, well, the body of the luminaire is the heat sink. But if you look at the way luminaires are designed now with aluminium, there's generally always more aluminium needed there than is needed for the cooling. So we need to use aluminium for heat dissipation, but by using a lot less, we can really bring down the carbon footprint of luminaires. I should say that this study was only cradle to gate, so we've only compared the raw materials. We haven't looked further at how this changes as we reprocess the material. So this will only go up because you have to remelt the aluminium, and the amount of energy needed to melt the aluminium, it's going up towards 1,000 degrees versus the amount of energy needed to melt the plant polymer. There's just a big difference there. So that process happens again, and these figures will only go up. So do the materials we use stand up to scrutiny? Yes, they do. But I should caveat that not all PLAs are made equal. So there's a huge range of different PLAs available from different manufacturers, and they have different attributes, including flexibility, mechanical strength, and heat resistance. PLA is probably not as standardized as other polymers. There's all sorts of different variations and formulations of it. This was a video, back 2 years ago now when we launched, there was quite a lot of comments on social media saying, oh, you can't use PLA, the glass transition temperature is too low, its heat deflection is not there. And so we produced this video of the material we were using to show, hopefully this will play. We filled it up, I 3D printed this in the same sort of wall thickness as our components. And it was absolutely fine. Boiling water, it doesn't warp at all. So the heat deflection properties of the right PLA, there's no issues in using them for luminaires. So the specific PLA and PHA materials, we use a robust with good heat resistance. We've done extensive in-house testing. We've also had independent glow wire testing, and they both passed the glow wire tests. One thing I would say is we wouldn't recommend using PLA for any exterior luminaires, just because it doesn't have elevated UV resistance. It's not to say that couldn't. There may be PLAs that can be more UV resistant in the future, but we wouldn't recommend using them outdoors. The rise of PLA in 3D printing. So PLA has become very popular. It's the most popular polymer to 3D print. And I think the reason for that back sort of 10, 15 years ago, when FDM 3D printing patents expired and everyone started buying desktop machines. They were using ABS quite a lot to start with, but the problem, ABS tends to warp when you print it, and there's toxic fumes that come from it. So very quickly people started using PLA because it was much easier to print. It didn't warp, and it was a bit easier to get good prints, and it didn't have the toxic fumes that ABS had. So it very quickly became the most popular filament to 3D print with. I think that's one of the reasons there's so many different materials out there, especially for 3D printing, is that originally it was all aimed at the hobbyist market. One byproduct of that is that there's all sorts of crazy finishes and material blends and exotic materials out there, because primarily people wanted something that printed well and looked cool. So that's driven these interesting materials. There are now PLAs that are much more suitable for industrial applications, like the ones we're using. And one thing that caught our eye at LumiAdd was the incorporation of waste into PLA. There's all sorts of products that byproducts that can be used to color and give different finishes. This is a project we recently did with Arup. We went to them with a light engine and said, you guys can do whatever you want around this light engine. And they came up with this leaf design, which we helped them develop. And the material that they chose, we gave them lots of samples of materials, and the one they chose was one that's incorporating reclaimed waste from restaurant streams, so crushed up oyster shells and scallop shells. And it gives the pendants a really nice finish and a really nice lit effect. So that was a great project, and it showed a lot of the advantages of 3D printing with the freedom of design, and it was a nice story. It tied in with the whole ethos of their Leeds office, which was to reuse. They reused a lot of the furniture and reupholstered it, and it was just a really great project to work on. So I thought that was just a good example of one of the projects, and it was a good one to end on. So thank you, and I'll hand over to Mark.
Thank you, Jamie. Fantastic presentation. I learned a lot, so thank you very much for that. Terrific. So I'll move quickly into Shoplight's story, which is around how we transitioned from a sales and marketing organisation into a manufacturer using PLA materials. So let me first just quickly introduce Shoplight to everybody. I've been in retail lighting for, well, about 25 years, but I've obviously stopped counting. And Shoplight is 10 years old this year. We've been innovating in retail lighting since 2014, and actually it was in around 2022 when we became a certified B Corporation that we started to look closer at the environmental impact of the products we were using, and really that started our journey towards 3D printing and manufacturing. But why do bioplastics matter? Well, as Jamie's very eloquently shown, aluminium comes at a very high environmental cost. And we believe that was something that in particular retail brands wanted to change, and they wanted to demonstrate that change to their consumers. Of course, as we all know, government targets, certainly in the UK, move around dramatically of late, but the targets seem to be a reduction of carbon emissions by 45% by 2030, and our government's still aiming for organisational net zero by 2050. And so aside from the environmental damage of aluminium, more latterly, there's also been legislative changes that are affecting either the price or the availability of materials. And that can include the ban on Russian aluminium that came through a couple of weeks ago, and the carbon border adjustment mechanism that has recently become law in the EU. So I will quickly move through these because, as I say, Jamie has very eloquently explained the issue, but aluminium does come at a very high environmental price. It's the materials used are mined, which in some parts of the world has links to deforestation, erosion, and contamination. And it has a melting point of 600 degrees C, although in fact the smelting process often goes up to 900 degrees C. And we shouldn't forget that the majority or a large proportion of major European lighting manufacturers, certainly in our sector, have moved the manufacture of their products for retail lighting across to the Far East 15, 20 years ago for reasons of globalization. And so it was cost effective, it was profitable, but in fact now, as we see 15, 20 years later, there's an environmental cost to that decision. Of course, there's also a cost of moving these products from the Far East into Europe and then onto the UK. 77% of the world's aluminium is made by 5 countries: China, Russia, India, Canada, and the UAE. And 34% of the EU's carbon emissions come from imports. And when you then factor in cross-border imports, this increases to 50%, which is why you can probably understand that they've taken legislative action through the carbon border adjustment mechanism. So both the US Treasury Department and the UK government recently sanctioned new Russian aluminium. And whilst, of course, that aluminium will turn up somewhere, for those who wish to procure their aluminium without this tainted supply, it increases the cost, and that cost is expected to increase further in the coming months. And I mentioned it a couple of times, but the carbon border adjustment mechanism is an EU-level carbon border tax on imports. It is already law, albeit currently it is a reporting function, which will shortly from 2026 move into the purchase of carbon credits dependent on the environmental damage caused by the imported goods. That includes hydrogen, cement, steel, and of course, aluminium. So if aluminium products are extensively used in the Far East, then it's likely the cost of these credits will be passed eventually to end users. And so there is a financial benefit to switching to UK-made bioplastic products earlier. So I mentioned that we moved to manufacturing following our certification under B Corporation. And that was essentially because whilst we totally appreciate that, that lighting energy through use is the largest contributor, it felt like the lighting industry in the main wished to ignore the environmental damage caused by both manufacturing and the raw materials. And so we launched Nort, which is our first biopolymer product in February 2023 at Euroshop. This is the one I have here. And actually that for us was a bit like cracking the code in terms of heat dissipation. But we now have a range of products: Nort GS, Cold Bio, Radar Bio, and in fact, only Monday we launched a range of decorative pendants that, as Jamie alluded to earlier, use waste from food products such as coffee, beer, wheat, scallops, mussels, and many other types of foodstuffs. And again, Jamie's very eloquently talked about the decomposition of these plastics. And in fact, we also believe that the future of these products doesn't lie in decomposition or landfill. In fact, it lies through taking them back and putting them back through the system. In a similar way, we've launched a buyback scenario. And in a sense, we're slightly fortunate because our client base, our end users that we deal directly with, but it means that at any point during the life of the product, our clients can return them to us and receive an incentive towards doing that so that we can put the products back through the system. And in fact, naught here is 86% recyclable or reusable, meaning that the vast majority of it we can put back through and create new products. So our goal is very much that in years to come, the majority of our products don't come from virgin resources, and that very few parts or products end up in landfill. And it's the financial incentive for that that we hope will drive a change in behaviour. So I think just to kind of end on the challenges, but you know, I think the one thing that there should be an understanding of, and I'm sure that everybody on this call has seen it, you know, there is a lot of talk about aluminium being the greenest metal, and that's very true. However, there are some complications around the recycling of aluminium when it's powder coated. It's difficult to get the paint finish off, and because typically the products used, certainly in our sector, are relatively low cost, the financial implications of stripping products down, separating them, and making sure that the aluminium goes back to recycling, the problems are very high. So I think as hopefully we're trying to do, and I know that LumiAdd is trying to educate in a very transparent way, it's also important that the aluminium manufacturing sector does the same, and rather than perhaps claim that because they're aluminium they're recycled, understand the process of recycling powder coated composite products, which is exactly what aluminium spotlights are. They're a combination of plastic, metal and other materials, and be transparent around that. The challenges that we faced were principally heat. Of course, aluminium acts as a very rudimentary radiator, and of course plastics tend to incubate, and in fact it was our patent pending Ventec that allowed us to ensure that we dissipate the heat through the product, and in fact it performs better than any of our aluminium products at ambient temperatures. And of course, the other challenge would be changing to a manufacturing business model. And we are fortunate in that we're not a legacy manufacturer. I'm often asked, why don't more people do this? And fundamentally, the answer is because they've invested millions of pounds into legacy manufacturing. And subsequently, the barrier to entry is quite high around amortization of investment. But nonetheless, it's a challenge that we've risen to, and one that will continue to do so. So that's everything from me. I'm going to hand over to Julien now, and hope to answer some questions a little later.
Hello.
Julien, yeah, we can.
Can everyone hear me?
Yes.
Indeed, yeah. The slides, I'm not sure the slides are. Oh, sorry, they are. Hi, everyone. Thank you for the invitation to this webinar. I think what's been covered with James and Mark is great, with the spectrum of, you know, the material and then the lighting. I think the last challenge that Mark mentioned around the manufacturing, I guess that's where we sort of come in. So to give a bit of an intro of Batch.Works. So Batch.Works has been around for 7 years. I've been involved in 3D printing for the last 12 years, and we're really focusing on leveraging 3D printing for circular economy models, and building decentralized 3D printing software and hardware solution to really move towards those net zero targets. And so we really position ourselves as, you know, on the sort of other end of in some ways of the expertise of Mark and Jamie on the lighting, where we bring more the expertise on the 3D printing. And I think working together to find those solutions is key. And I think so Batch.Works is really our sort of big vision is to help the world to design and manufacture products sustainably, and obviously lighting is part of our business among other markets in retail and consumer products, and really the mission is around what I think, as Mark mentioned, around aluminium is broken. Supply chains hurdles, the high CO2 emissions, high costs, standardized products, and long lead time are really some of those that Mark mentioned and sort of well known in the press, and we've seen in the UK there's 90% I think of the manufacturers are looking at reshoring manufacturing. So we are in that dynamic, and so we need to innovate in those manufacturing methods to achieve those new products, achieve the circularity model that have been in theory for so long. So we're currently operating, our headquarters are in London. We have 2 factories, one in Hackney, London, and one in Eindhoven in the Netherlands. We operate about 80 printers, and we're really focusing on the software and hardware solution to bring those products to market and scaling them. Is really that's one of the big challenge. And so going on those challenges of 3D printing that it faces, I think it's 3D printing has been around for a long time, and we're now coming into the end of a sort of a 10-year cycle. So we see a numbers of challenges within that technology to scale it in order to achieve those products, and it's really the fact that it's not necessarily trusted for quality and reliability, the fact that you need specialized skills for the design as well as the operations of the hardware, which make it really difficult as a technology to adopt a large scale. 90% of that technology is used for prototyping and tooling, and there's a lack of infrastructure to support volumes. And what I'm saying volumes is, hundreds of thousands of parts, millions of parts, really having an infrastructure that allow those volumes. And also, it's inefficient currently at this stage. So the failure rate is at least 20%, and so we've been working a lot on trying to drill down that sort of quality process, those automation process to scale those products, which will allow lower prices and enable those factories to leave in the UK where the demand is, and that's really the key point. And so the way we unlocking this through Batch.Works is creating a hardware and software platform that's closing the gaps, the skills gaps, both on the design side as well as on the operation side. So it's an end-to-end platform that just allows both on the designer fronts to prototype and production products and be ready to deploy for large volumes. At the moment, there's too many sort of scarcity between different type of 3D printers, and there's so many on the market, and you still have to go through so many layers of software to actually get to parts. And it's really about bringing that awareness. I think designers at the moment, they use 3D printing as a prototyping tool, I was mentioning, which means they're not designing for that technology. And if you think of aluminium manufacturing, this is a well-known process. Design engineers and engineers knows how to design for those processes, extrusion process or milling process. And so there's a huge piece around how do we design for 3D printing. So every grams counts, every minute counts. So it is a scalable solution where quality is coming right from the start of the design process, as well as the circularity. So I think in order to be circular, you need you need to bring those tools right to designer so they can implement circular design, circular principles right from the ideation stage. And so with all our clients, we're really working from that design stage to the full cycle. So we're building this platform, which is AI driven and has all the built-in circular principles from material supply to the end of life of the product. And then the designer is able to see the life cycle analysis and impact data right from the early stage. And that's really enable the creation stage to take the right decisions with the right information. And I think that's really what we're trying to build. And so as I'm mentioning, we're sort of this is one of the projects we'll be doing. It's not lighting. It's a Kibu headphones. It's the world first circular headphones that you can repair. You can build, repair, and recycle. And that's to bring the point of looking at how every piece needs to be designed to be repairable, to be teared down, and I think it goes back to Mark's points on the powder coated aluminium. This is monomaterials. It's really easy to disassemble, really easy to recycle, but that's because that headphones has been designed right from with those principles in mind, and that's really a key element here. And so we're combining processes. We're also using laser cutting to implement really fine details that are needed. So we're combining really efficient high-speed 3D printing with some other digital tools that just make sense to use to combine with. And so the way we to come back to that methodology, which applicable to all sectors and specifically lighting, is obviously looking at the analysis from the early stage. And so every time we work with a client, it's looking at their needs, looking at the material they're currently using. So we're working with one of the largest retail in the UK, where we're doing fixtures and fittings in stores. And the way this project was designed is essentially walking around in the store, identifying bits and pieces that are currently made in a very traditional way, high CO2 impact, high cost for them because they have to have stocks and complex supply chain supply and replace those pieces. And so now they have solutions where we can use their own waste from their retail packaging or other wastes. And those files can live in a digital warehouse. So if they need to replace a light or they need to replace any fixtures, it's a matter of a button to essentially replace those parts, us taking this material back. And so what it creates material being part of, I think plastic in general is something that is not valued because it's quite cheap material. And I think in those circular methods, plastic is becoming, an asset that you can use and reuse. And so we're working on this material credit where every product has an embedded material value per gram that is reusable X amount of time, and that can be re-implemented within the business model with our clients. So when you take a building down, you take the lighting down, you can use those material credits to essentially remanufacture to the same clients or to another client. And so really create those loops that, which are the principles of, the circular models. But it does mean it comes with this lots of challenges. It does mean you need to nail the design stage, be able to manufacture and manufacture in a very local and controlled way, as well as being able to provide quality at all stages. And so that's where AI is really interesting, because we can implement it in all those stages, ensuring quality to our clients all throughout this circular loop. And so that's really excited to be releasing part of the software soon, but in the meantime, we're working with clients to deliver those products, and this is more of an outline of the pieces of what 3D printing means and what it can enable for circularity. Shorter lead time, short supply chain, reduction in CO2, that was already mentioned by Jamie and Mark, and just the fact that there's control of that supply chain is a massive cost saver. I think so many times we look at the unit cost, which is obviously really important. We're not really looking at all the hidden cost of, well, you need to hire someone to manage that supply chain, you need someone to manage those stocks. And so by having this really agile model, you're actually able to be a lot smarter in terms of SKUs that you're using, a lot more bespoke to the client without a massive premium. We really excited to be bringing those innovative materials, processes, and working with sort of all sort of widespread of businesses to make this happen and be the new standard. Thank you, everyone. That's it for me today.
Great stuff, Julien. Very interesting. And if I could invite Mark and Jamie and Nigel to join us. Nigel, by way of introduction, I presume this trend is something you would welcome as a general rule?
The story behind the reduction in embodied carbon by using bioplastics is really compelling. I think that's fantastic, and so on that basis, it's a really positive development. We need to understand what we can do to support it.
Mm-hmm. There's a question from Sunjit Sal, who's the engineering manager, I presume, at TRT Lighting, and I noticed something that was one of your concerns, Nigel. He says, at the end of life, can bioplastics be readily recycled, and how do they directly compare to traditional plastics such as polycarbonate? So, who wants to take that one?
Ray, I'm sorry. I'm happy to jump in. I think there's a couple of things here that need consideration. I think before we get too far down the line of how do these materials get split apart and recycled by third parties, I think there's a bigger piece, which is the lighting industry taking more responsibility for its own waste. And I think that there is a challenge, but I think ultimately businesses like LumiAdd and like Shoplight actually tackle that challenge head on, because we want the product back. And so the issue of recycling becomes one that we can answer directly, rather than just pass the responsibility on to a third-party recycling body. Now, I think it presents challenges to Nigel. I think ultimately, if the lighting industry does take responsibility for its own waste, that may have a business model impact on Recolight. But I think fundamentally, the questions that the industry should be asking is, how do I take care of my own mess, rather than how does somebody else take care of my mess?
I totally agree with that, Mark. I think the fact that there's no infrastructure for recycling polymers like PLA isn't a reason not to use it. And even if it's just the interim where we take back the products and we know what they are, and we can regrind them in-house and re-extrude and reprint with them. And then as more adoption of these materials happen, then the infrastructure will follow. At the moment, there isn't the infrastructure to recycle PLA, but as Mark says, we're both tackling that one. We have, on our fittings, we have QR codes that takes you straight to the buyback scheme. And we want these back, and we don't necessarily need to recycle them. We can reuse them. And that's a better, I mean, recycling, we should firstly be reusing if we can, and remanufacturing and recycling as the last option. So I think in the interim, taking responsibility ourselves is a good solution.
And just to add to that, I think we would always encourage any manufacturer of fittings to actually look in the first instance to try to take back their own product, whether or not they contain bioplastics, because actually they are always going to be the best organization to remanufacture those products and supply them back into the supply chain with, again, a much lower embodied carbon if all they're doing is remanufacturing, converting, for example, a fluorescent fitting to LED. So taking back your own product is always going to be the better solution than allowing them to go to recycling. Recycling is not the best environmental outcome.
And I think to just add to this is, it means we can change the model, the way those lights are bought as well. And so if you implement that materiality and that circularity at the start, then you're actually able to be like, to incentivize them to return it financially, you know, because then it's not becoming, oh, just buy this piece and, you know, please take care of your own mess. I think it can be embedded within the sales story and within the initial conversation as a selling point, because by recovering the material back, you're recovering money. And because the recycling process and the remanufacture process is simple, it's not like fashion where, you know, the remanufacturing be too expensive, therefore it doesn't work. There, by sending us back, you're sending us raw material for us to reprocess and make money of. And so I think there's a really interesting model there which can be implemented much early on to then incentivize them to do it. And I think that's where it's really interesting.
Nigel, I know it's not the preferred option, but if Recolight gets bioplastics, do you have a sort of a method or a policy or as to what happens to them?
We've never yet knowingly received a batch of bioplastic based luminaires. I mean, at the moment, our main challenge with plastics recycling is actually recycling plastics which are legacy from, you know, a decade, 2 decades ago. And so for us at the moment, a big issue is the persistent organic pollutants that were put into traditional plastics that cause lots of problems nowadays. And so what we're always doing is looking back in the rearview mirror for what was happening in manufacturing a decade or two previously. Clearly, in a decade's time, actually, you know, how we tackle a mixed batch of product that would contain some bioplastics and some traditional plastics is one that we will have to understand and manage, because that will happen undoubtedly. Even with the best buyback systems in the world, there will always be situations in which there is a mixing that is going to take place. So it's going to be an issue that we will need to look at certainly in the future.
Having been to the sweep that plant down in Kent that you guys use, you have a very quite a fast moving conveyor belt. How they sort material and detect bioplastics from non-bioplastics, it baffles to me, unless there's some technical way they can look at it.
The way it happens at the moment for plastics that contain brominated flame retardants, POPs, is actually the granulated plastic goes through a density separation process, which is in saline, and that saline allows the heavy bromine containing plastics to drop to the bottom, and the non-bromine plastics, you know, go to the top. So there is a method of separating out different types of plastics in that situation. Clearly, we will need to understand how to tackle this in the future, but that could still result in feedstock coming back to Shoplight and LumiAdd and others as a result of that separation process. But clearly, I'm certainly not aware of a technology that's available at the moment to make that separation.
One of the points that they did make was, you know, we need labeling. Have you got a battery in this? What is in this? They want labeling so they can see clearly, not a QR code, just a big arrow, because the thing moves so fast. Well, let's dive into take some more of the questions and get through them. A couple of questions about the glow wire test. Elias Kern Bickler, who is the product manager of Tridonic, says, How does the behavior of bioplastics compare to those of standard variants, especially in terms of glow wire testing? And Christoph Hujak, who is the technical engineer at Glamox UK, also is asking about that. He says, which parts of luminaires can't be 3D printed due to failing the glow wire test or similar test? Jamie, do you want to take that one?
Yep, I can take that one. So the materials we use have passed the glow wire test in the thicknesses that we're using them and where we're using them. We haven't, I mean, the only parts we come across that we don't 3D print, it's not because they failed the glow wire test, it's just that they don't have the characteristics we need. So the optics, for instance, we obviously don't 3D print. Obviously the heat sink we don't 3D print because of the heat dissipation. But the materials we're using have passed the glow wire test, so there isn't an issue there for us.
So there's no issue with you, Mark, either, and glow wire testing hasn't been a problem or anything? No.
No.
Sorry, Jamie, go on.
In terms of how they perform, you know, when compared to conventional polymers, as I said, there's such a wide range of different PLAs available, but there's ones with enhanced mechanical strength that perform as well as ABS. There's ones with elevated heat deflection temperatures. So although it's a bit of a minefield at the moment, because as I touched on, the drive for PLA came from a hobby market, there are now materials that do what we need them to do.
By using additives, I presume, is that how they do it, Jamie? Yeah,
I mean, the supplier we talk to, we always ask if the additives are bio-based additives. And we try and find out as much as we can as to what they put in them. And there's other process. I mean, you can heat treat some PLAs to enhance and there's different formulations with different crystalline structures, and it all gets quite technical. I'm not a chemist, but there's a lot of options out there now.
Okay. Stuart Lawrence, who is the purchasing and planning manager at Design Plan Lighting, is asking, can PLA be used an alternative to polycarbonate in diffusers?
We've played around with using it as diffusers on some sort of opal varieties, and they don't perform optically as well as the you know, some of the very high transmittance diffusers, and I mean they just haven't been developed for that. So decoratively they can be used for good diffusion, but if you're concentrating on efficacy of your luminaires, we don't think they're quite there yet. But that's not to say
we've got some we did a couple of diffusers using custom formulas, but yes, there's I think with some custom there are we've done some for a client, and it's a specific formula that is better for diffusion. I know company Gantry in the US, they have custom materials that are better for diffusion. I mean, I'm not a lighting expert, but we have similar materials for a client, and it seems I think there are viable ways, but definitely it's far from, as you say, Jamie, to be standard out there.
Okay, let's talk about prices. Let's talk about money. Stuart Lawrence again, do prices and minimum order quantities for bioplastics currently differ much to non-bio?
Ray, I don't mind stepping in. I don't know. And the reason I don't know is because we've only ever used bios. Yeah. What I can tell you is that, you know, when you look at the full life cycle of the luminaire design, development, manufacturing, you know, I think our initial thought was that there might be a tipping point where 3D printing becomes less economically viable than, say, injection molding. But what we found in reality is first of all, the 3D printers get quicker and quicker, and that's principally by firmware updates and that type of thing. But also that, in fact, what happens is that if you resort to traditional manufacturing methods, whether it's through aluminium use or through injection molding, you remove many of the real key benefits of 3D printing, and that is you know, design on the go. You can amend the product at any point. You can change the textures, the thicknesses. You can create bespoke products, and so actually we tend to find that certainly we're at a point where from a price perspective, our first product launch was a premium product, no two ways about it. But frankly, subsequent to that, we're only launching products to our clients that are an equivalent price to aluminium, because we believe, and it's been borne out by our clients, that they want sustainability. They're desperate for it, but they don't want to pay any more for it. And that won't surprise anybody that retailers might demand such a thing. So that's been our goal, and it's certainly something that we've achieved from product 2 onwards.
Mm-hmm. Is it? Would you say, Mark, that they want, when they want bio? Is it for the backstory, or is it a genuine?
It's both. It's both. I mean, I think, being brutally honest, we've met retailers who've said we want it because our investors insist on it. That actually for them to release the money to build the shops, we have to have a sustainable story that we tell. There are equally those who are frankly as passionate about it as we are. So it's a real mixture. But look, my view is that so long as they all drive towards the same outcome, the reasons behind it are, they can be a multitude, can't they?
Mm-hmm. Is there some sort of metric they're trying to hit, or some sort of are they driven by something like neighbours or something like that?
I think it's driven by brand. So it's no secret that Gale's Bakery were the real first uptake of biopolymer products from us, and everything they do within their stores is driven around sustainability. So they use a furniture manufacturer in Oxford called Raw, who actually take kids who are in Last Chance Saloon and train them how to be carpenters, right? So there's a social or an environmental aspect around everything that they do when they're building a shop. So and that all feeds into the story, Ray, right? So I think that's the art of retailing, right?
Mm-hmm. Craig Cawley, who's a senior buyer at Whitecroft, is saying, how do we ensure the material comes from truly sustainable sources with a low environmental impact?
We have an LCA for the specific material we use, which tells you exactly where it's made. It's in Thailand, and there's a lot of information there, and that gives us confidence that it's coming from a sustainable source.
Yeah, and sorry, go on, Jamie.
No, that's okay, Julien. Let's go ahead.
I guess that replies another question that is on the chat around the use of virgin versus recycled PLA. So in our case, we use the recycled PLA that is from recyclers from the Benelux regions, the Netherlands. It's really good at recycling, and so we use 100% recycled PLA, which is the credential. The CO2 emission on this is insanely low, even compared to virgin PLA, which virgin PLA is already really low compared to like petroleum-based plastic. So I think it's and similar to Jamie, I think there's a lot of data around that to give accurate numbers on those CO2 emissions.
And if I may as well, Ray, just to sort of punch back a little bit, there's lots of lighting manufacturers out there claiming that 100% of their aluminium is recycled, and I suspect not many of them can determine whether that's true or not. So I think there's a whole piece around the transparency of materials, full stop. There shouldn't be a difference between PLAs and aluminium, right? So if you're using recycled aluminium, then you'd very much hope that could also be demonstrated through either documentation or through the supply chain.
Wouldn't that get picked up if you're doing environmental data like TM66 or TM65, that would be picked up surely?
Yeah, I mean, Jamie might have a different view, and possibly Julien, but they're not quite aligned to 3D printing and
really,
and PLAs. Equally, a lot of EPDs don't cover the option of including PLAs and 3D printing as a production method. And really? The answer historically seems to be, we'll pick something that's close, which to me doesn't really do justice to what it is we're trying to do. But look, this is relatively early days, and I've no doubt that as time progresses, the refinement of that data will get better and better.
Mm-hmm. You basically, your point is you don't get the credits that you guys deserve. You'll get the benefit in those metrics.
Yeah.
I think the TM66 is largely about the design of the luminaire and separations of materials, and so. But Mark's right. There could easily be extra stuff in there that we can't get points for. That we're currently doing that is more sustainable and circular. And TM65 equally, there's no material drop down for bioplastics. I mean, timber is pretty much the same. It's very similar carbon footprint. It's the closest one in TM65, so we can use that. But at the moment, they haven't. I don't think they've quite. I think it's just a timing thing, and hopefully revisions can maybe look into it. But going back to how do we make sure that the feedstock's sustainable? I think at the moment most of the feedstock is sugarcane, but the other polymer we're using, PHA, successfully been made from waste. They've even managed to make it from sewage in the Netherlands. And so if we can start making polymer from waste, I mean that's like the holy grail, isn't it? That you take sewage and turn it into plastic products, and then it biodegrades at the end of it. And we're a long way from that, but it needs investment. It needs more people to start using biopolymers and try not to think of reasons not to use it, because obviously infrastructure's not there, and look at where we could be if it's adopted more widely.
Irina Matsai is the sustainability lead at Stone Lighting, is asking, this is specifically to you, Jamie, was the comparison of CO2 emissions, PLA versus aluminium, made considering secondary or virgin aluminium?
No, it wasn't. But
it was virgin aluminium you were comparing it to. Okay.
Yeah, but I think whichever way you cut it and you take that comparison, as I said, it just takes so much more energy to dig something up out of the ground and melt it at a much higher temperature than grow it and farm it. So like I said, we need aluminium. I'm not saying we don't need aluminium for luminaires, we absolutely do, but we maybe don't need to use as much of it.
Right, we have Simon Fisher's asking, are there any regulations driving the market, driving marking of bioplastics? I can't see how the industry can rely on take-back capturing all the e-waste. Identifying and removing biomaterial from the regular e-waste recycling process of almost impossible currently, and organic material contaminates recycling of dinosaur plastic. It would be good to be able to mark and clearly identify biomaterials. Something you guys agree with?
Yes, I agree. It needs to be labelled properly, and then hopefully, as it's adopted, that then there is infrastructure to recycle it. But it's a chicken and egg thing, isn't it? No one's going to have the infrastructure to recycle something if no one's using it. So it's not a reason not to use it. We just need to find, workarounds in the interim.
But there is no regulation that you know of that's saying about marking or labeling.
I'll be honest, I'm not sure. I've seen lots of PLA products that have the PLA marking on it.
Yeah.
I don't know what the regulations are that tell you if you have to do that or not.
What's just a special symbol? Is there? Is that right?
Yeah.
Okay. Okay. Hannah Smith is asking, what is the expected lifetime of 3D printed materials? For example, many aluminium streetlights are required to have a 25-year design life.
Yeah, I mean, as I said, I wouldn't recommend using it externally, but that said, I've been 3D printing things in biopolymers for decades, and they're all still in fine working order. Even if some of the stuff that's out in the garden, it looks a bit worse for wear. So I think they have the same longevity as a lot of conventional polymers, but obviously an external environment, I wouldn't suggest using the ones we use.
Do you quote a lifetime, Jamie, for your products, or in terms of hours? Or
we obviously have the lifetime of the luminaire and our 5-year warranty, and we have no worries about anything happening in an interior environment to our luminaires. The polymer will last as long as conventional biopolymers.
And Ray, if I may add to that, certainly some of the polymers that we use can be repurposed up to 12 times without losing any thermal or mechanical strength. So if you might imagine the life cycle of a store fit is 7 years, say, you've got, best part of 100 years use from that product if you can put it back through the system every 7 years. So certainly the producers of the PLAs are very confident around the maintenance of the materials for a prolonged period.
Okay. So I was one statistic did jump out at me, Julien, which was this thing that 20% of parts fail. Is that like 20% of 3D printing jobs don't go to completion for some reason or another? Is that correct?
I think yes. So I think for us and I think that goes back to some of the question in the chat on scalability of that technology is because products are made one by one versus using a tool. Obviously, injection molding will have a massive waste sort of up front on the test runs and everything. But with 3D printing, if we do a run of 100 pieces that are the same, same file, same machine, same material, you will have 10-20% that will not pass quality. And that's because that's more of a technology problem. And that's where AI can be really interesting in monitoring those processes. And so we've put essentially cameras on the machines that can analyze live imagery to feed back to the software. So one of the issues of 3D printing, when you start an object, it can fail. If the object takes 4 hours, it might fail within the first 5 minutes, and then just carries on, and you come back the day after, and that's straight to the bin. And so you wasted energy, you wasted materials, and so there are big barriers to scale that. Is at the moment there's no solution out there. You can't buy an off the shelf factory with 1,000 machines that will allow you to make 1 million pieces a month, or a day or whatever. So at the moment there's a big boom in the consumer market. So there's a lot of consumer printers you can buy, and which is great. It brings awareness of that technology. But on the industrial level, what you find is actually just highly complex and not really suited automation system, which is more about they make hardware and software to make prototyping faster, but actually nothing about how can I make 10,000 of those lights, a week or whatever. So I think it's definitely lacking those solutions to scale.
Presumably those 20% you just put straight back into the sort of research.
Yeah,
so
of
it's
course.
just a tolerance.
Yeah, of course. Yeah, exactly. So obviously we're processing the material, but it is a waste of time, a waste of money, a waste of, and the material is degrading anyway when you're processing, right? So that's a big piece we want to sort of bring down to a much lower rate of failure.
I have to say our failure rate's not that high. There are failures, but I think, but Julien touched on this, is there's a degree of skill in running 3D printers, and if Joe Bloggs goes and picks a desktop printer, he's probably going to have lots of issues with it. But once you have experience running the machines and maintaining them, you can bring that failure rate down. But I think probably is an issue for really large scale. I think.
Yeah. And I think the big pieces is there are products where we make 1,000 of them a day, and so where the quality requirements of the client is really high, and so something that wouldn't be considered as a failure to sort of the 3D printing world is for the end clients. And I think it's and sometimes it's a small thing. They think, oh well, that would be fine. And I think this is where do we put the sort of, because the failures of the printer failing is one piece, and that's like related to the hardware and but it's more around surface finish or operators failures or because when you have to look after much larger fleets, the operator failures or the extrusion or the materials is then, you know, there's a lot of components that makes it that this part is not going to go through quality. And it definitely varies, you know, it definitely varies depending on the product and the kind of print it is. But it's definitely a big one.
Nick Whitehand is asking, he says, will the carbon-free aluminium born from the new ELYSIS revolution change the game? Is that something on your radar, guys?
I don't think so, because it's not really carbon-free aluminium, is it? I mean, they're not. There's not the carbon being given off in the process, but the energy they use still has a carbon footprint. So I think it's a great development, and it's obviously gonna narrow the gap a little, but you still got to melt that aluminium to near, you know, not far off 1,000 degrees. So I don't think so, although I welcome it, and I don't want to come on here saying, you know, everything bad about aluminium. It's a great material.
If I may, Jamie, I second your thoughts there, and I think, of course, if we can get aluminium that doesn't emit any carbon through the manufacturing process, then that's also great for the heat sinks that both Jamie and our company put in our product. So in fact, it would also have a positive impact on our own products as well as those made from aluminium. But again, I think James absolutely right. It doesn't remove the mining. It doesn't remove the energy used through the smelting process. So yes, it's better, and it's a really positive sign. But you know, it certainly isn't utopia for aluminium.
Although I presume if you used, you know, renewable energy for the smelting process, it would be low carbon.
Yeah, but go back to the data there. I mean, 76% of all aluminium is manufactured in China, India, Russia, the UAE, and Canada. And whilst you might take, at this stage, you might take Canada out of that, you know, the majority of those other 4 nations are predominantly using coal-fired power stations. So yeah, you're right, and maybe in future there'll be more renewables used in the production of aluminium. But and I should say that over 50% of the world's aluminium is produced by China. So those other 4 nations are actually very low contributors to the overall total. So yeah, I mean, again, that would be a great step, but I think it's one that's a long way removed from reality right now.
Yeah, it's a few years down the road, but companies are actually using it now, aren't they? Like Audi and Apple and all the rest of it.
Yeah.
Paul Stockley is asking, how many times can the material be reused before the properties change?
Yeah, as I mentioned earlier, certainly the polymers that we use are up to 12 times reuse, and they'll happily sit there for probably 10 years per event. So yeah, I mean, you know, I'll be on.
Daniel Bambas, hope I pronounced your name correctly, is he's talking about, you know, can we bioprint bioplastics for external parts for outdoor lighting applications? So presumably, is there an additive, or is there been any studies that could withstand?
Yeah, there are. Yes, additives is the answer. You can have. We have one of a supplier doing exterior cladding for architects that are UV resistant, temperature resistance. I think it does compromise the sustainability and the credential of the materials, but you know, similarly to injection molding, you know, you can make recipes that are durable for exterior. They're a lot harder to print with, but it is possible. And I think a great one is probably, I mean, it's not a bioplastic, but it's a recycled. There's a great company called Fisher Filament recycling fishing nets in the Cornwalls to turn, and you know, those are, you know, materials we can use in 3D printing that would be absolutely fine for external application. I think with bioplastic, you definitely have to use quite a lot of additives to make it work.
Peter Scotsman is saying every luminaire has a driver fitted in a plastic case. Where are the driver manufacturers in this story?
That's a brilliant question, and I think probably one we'd all share. But That said, there are steps being made, and forgive me, but I think it's Osram who are already using a proportion of recycled plastic within their driver cases, and maybe Jamie and Julien know of others that are taking that step forward.
Okay. Well, if there's any driver manufacturers on, please post post what you're doing in the chat. Tony Kelly is asking about where do we see this going in terms of large scale production. I think you talked about this, Julien, didn't you?
Yeah, I think it's well, we're already making, you know, thousands of products. It's a matter of, as I was saying, you know, it's a technology piece, an infrastructure piece, and that's pretty much it. You know, at the moment, there's no machinery, hardware that really allow this scale yet. So we've developed a printer that has full automation that can run 24/7. With automatic, you know, feedstock management across a large fleet. And so that's pretty much it. I think it's a really simple answer. It is possible to scale it. At the moment, there's no solutions to host that in one place. At the moment, it has to be very manual. You put printers on a shelf, there has to be manned very. It's almost buying 100 paper printers, you know, home ones, and putting them on a shelf. And the automation that's being put out there doesn't fit, as I mentioned, the needs. It's just making prototyping faster, but not really scaling it. So it is possible, and as long as we don't need designs per day, like, you know, plastic bottles or mass consume items, then, you know, to reach those volumes, it's very possible.
If I might, sorry, Julien. So Ray, if I might add to that, and to put some perspective around it, you know, we expect to supply in excess of 30,000 3D printed biopolymer products in the next 12 months out into the market. So Julien's absolutely right. You know, if we talk about mass scale in the form of Coke bottles, then we're a million miles away, right? But if we're talking about the production of luminaires that are all specific to particular clients or projects, and therefore there's always an element of bespokeness to each one, actually, as far as we're concerned, it's both viable and cost effective, and be interested to see if Jamie backs that.
Yeah, when we first started LumiAdd, one of our concerns was, you know, the print time, and is that going to be the issue? And we found it's for us anyway, it's not the bottleneck at all. It's all the other things that all the manufacturers have issue with lead times and assembly. And I think there's an element of you have to design for 3D printing. We do print some parts, and for other manufacturers come to us, they want some custom parts and things, and they might chuck a design at us that's for injection molding, and we say, well, we're going to have to redesign this because it's going to take too long to print. This bit won't print well, the orientation's wrong. And so if you get in the mindset of designing for 3D printing and you design for 3D printing, you can bring the print times right down, and then all of a sudden the volume isn't as much of an issue. I think there's just a different way to design for it, and ways to overcome those problems.
We talk about composting, but how these industrial composting environment, are they common? Is that easily done? Is there a lot of them around?
At the moment, I don't think there's any in the UK, at least, any industrial composting facilities that will take PLA.
Mm-hmm.
Ray, there is a particular material that we use in one of our products that just requires electric composting for 90 days, and then what's left can be buried back into the soil. So there are some PLAs. There's no colorant in it, which is very important, so that it doesn't leave microplastics behind. Mm-hmm. But there are some materials that are almost consumer costable with a basic electric composter.
Oh, okay.
I guess just as you know, we try to encourage remanufacture and avoid recycling, we'd much prefer to see PLA and other bioplastics coming back into the supply chain for reuse as material rather than composting.
Emilio Hernandez is saying a lot of the comparison today has been between the recycling of PLA and aluminium, but aluminium can be refurbished, which is a preferable circular principle to recycling. What are your thoughts on the longevity of 3D printed lighting? But I think he's referring to, you know, remanufacturing, the fact you can reuse the housing as it is.
Yeah, I mean, I again, you probably sort of asking the converted already here, but you know, I've got it on good advice that most traditional luminaire manufacturers have a remanufacturing level of sub 1%, and when you consider that most don't remanufacture, then there's still a huge amount of aluminium that could be repurposed. That is, so again, I sort of push the question back to legacy manufacturers and say, perhaps the real question that should be asked is, what are they doing around getting their materials back and either repurposing them or making sure that they're stripped down ready for recycling, which is the sort of elephant in the room that many traditional manufacturers don't really want to talk about.
Yeah, I think to add to that as well, I think remanufacturing is great, and the more we do of it, the better. But you can't remanufacture anything, and if you get a big lump of aluminium back and you can't change the style of that, there's lots of barriers as to changing it into something else. You're basically just remaking the same luminaire, and if technology changes and styles changes and things, then all of a sudden it's not quite as viable. On the flip side, if you get a 3D printed luminaire back and you just strip it for parts, regrind the material, you can reprint it however you want it. So I think remanufacturing is great, but it's not, you know, it's not the silver bullet. We can't remanufacture everything, but the more of it that happens, the better, I think.
Mm-hmm. I do know firms like Stone Lighting do make a play of the fact that they do design their luminaires to be less, you know, items of fashion, and that they're sort of classical, and therefore, you know, they don't date, basically.
And I have great admiration for Stone Lighting and what they do. So, you know, hats off to you.
And just to agree with Mark, I think that the level of remanufacture is very low at the moment. You know, if it's nudging 1 or 2%, it would be an optimistic number.
Lorraine Calcott, who's the director and principal designer at It Does Lighting, is asking, biodegradable plastic is still plastic. How can we move away from plastics altogether?
Well, I mean,
is it still a plastic?
With the greatest respect, well, yeah, technically it is, but with the greatest respect, we'd probably all defer, Lorraine, back to the last, hour or so, where we tried our very hardest to define the difference both between traditional fossil fuel-based plastics, and biopolymers, bioplastics. So there's a great difference. Sorry to
interrupt, Mark. I should point out that that was Lorraine put that as that was a preloaded question, so she put that ahead
Sorry,
of the
Lorraine.
Yeah. So I just put that out. I'm sure she just popped up on my feed.
Sorry, Lorraine. That was Ray's fault. I do apologize.
It's my fault. Sorry, Lorraine.
I think plastic at the moment has a very bad name, and it's mainly down to single-use plastics. So they're the major problem. Plastic is an amazing material that we absolutely need for so many different things. And if you imagine life without plastic, I think, you know, a lot of things that you take for granted would just disappear. So I think plastics are a problem. Single-use plastics are the biggest problem. Making good products that last and can be remanufactured and recycled with plastic is not the issue, in my opinion.
I would agree, Jamie. You know, single use is where the major issue is, and actually, plastic in the right product, in a durable product, is a good use of resources.
Okay, well, we've exhausted our questions. Before we finish, what has been the biggest challenge you guys have had with using so-called bioplastics, PHA, PLA? Jamie?
In the beginning, it was heat management, and then we moved to materials with the better heat deflection and designed thermally, so it's no longer an issue. Yeah, and one of the things we were worried about initially was surface finish, because you do get like a layered finish, but the reaction that we have when we're showing people the products on desktop studies is that they all really like it. So we were worried about the surface finish, but actually on the products
perfect,
themselves, I don't know how much of that picks up, but it didn't turn out to be an issue, which is good.
I should point out that Julien has got a hard stop, so he's rushed off to another meeting. And if you have any questions specifically of Jamie, we will pass them on if you pop them into the chat still. So there we go. Mark, same question to you. What was the biggest challenges that you faced when you made the move to bioplastics?
Yeah, I mean, similarly to Jamie, our initial challenge was around heat management, and particularly with we knew that a track-mounted spotlight would be the hardest nut to crack on that, and we partnered with an ex-Dyson engineer who actually was incredibly helpful in helping us achieve our goals. But I think really from there, frankly, the biggest challenge is around making sure that the story is well understood, making sure that people understand the benefits of the products, in particular, closing the loop and making sure that it's truly circular, which I think certainly for us, and I believe Jamie as well, we're there. And meeting the challenge head on of, like I say, of our perhaps our competition and our peers that answers the questions around the durability, the supply chain, all that kind of stuff. I mean, I think I saw a question pop up there, Ray, around how long does it take to manufacture a Nor product, and my facetious answer is about 47 days less than it takes for an aluminium one to sit on the sea. So I think that's the story that we need to explain to people over and over again. So yeah, they're probably the two challenges.
Lorraine Calcott has another question. For street lighting luminaires, are you on the approved lists of local authorities, and what are their views on these practices? Are you working with, say, Urbis or Philips, etc., to make their product bodies in these new materials? And if not, how can we design with approved luminaires for this market?
I'm afraid we're not in the street.
You're not in the street lighting game, and neither are you, Jamie. But are you aware of any issues there getting on approved? Would that be an issue if you had a PLA body?
Externally, I think that might be an issue, unless it had, as Julien said, additives. But yeah, we don't do any external stuff, so.
Yeah. And I presume when you guys talk about heat issues, you're talking about the fact that you get keeping that LED module to its stated window, correct?
It's just managing the heat so it doesn't affect the polymers, which is an issue for polymers without the elevated heat deflection temperature. But now there's polymers available with much higher heat deflection temperatures. It's the same issue, and I mean, you don't want the junction temperature of your LED going past a certain point anyway. You need to keep the lifetime. So in the beginning it was a challenge, but we overcame it quite quickly. And as Mark said, the track spot is the tricky one, because it wants to keep the heat in the body, so you have to let the air out. And but yeah, we're talking about heat affecting the material, not necessarily. Yeah, does that answer the question?
Yeah, I think so. And Mark, you've got that vent. You've got that sort of venting at the top of your luminaire. That's a heat management.
Yeah, we use, like I mentioned earlier, we have a patent pending on the cooling system. We call it Ventec, and essentially it uses both the Venturi and Coanda effects to draw ambient air through the body over the main heat points and extract through the top of the product. And yeah, that was the main challenge, and certainly that's where having an industrial inventor from Dyson helps.
Good. I should also point out that at Circular Lighting Live this year, we will have, and I just need to remind of his name, Bart Mayens, who's the head of 3D printing at Signify, and those guys have been doing using some bioplastics. They don't call it bioplastics, though. I think they call it biocircular. So I don't know. But that's just finally, before we go just on names. I mean, biocircular, bioplastic, plant polymer. They're all variants of the same things, Jamie.
As I said, to start with, bio is just such a, it just gets stuck in front of everything these days to make it sound green. I think people need to drill down into what bio means and what the feedstock for the material is. In general, I think it's a great move to work towards using bio-based polymers.
Okay, good stuff. I think we'll wrap up there. We're nearly come to 12:30. Thank you, Nigel. Thank you, Jamie and Mark, especially for lots of positive comments coming in. Thanks for your time and for sharing your insight. I know, you're sharing your insights sometimes with people who are, fellow lighting manufacturers. So we really, really appreciate it. And as I say, we have a special session on this at Circular Live, which is on the 9th of October at the Royal College of Physicians, and there's early bird prices. So if you dive onto the Recolight website and just follow the links, you can ensure your place. Good stuff, guys. Enjoy the rest of your day, and thank you so much again for joining us.
Thank you.
And thank you very much, Ray, for guiding us through a fascinating session. Thank you.
Very interesting. Thank you.